78 meters below the ocean floor, a high-speed train will soon race through the solid rock while ships pass quietly overhead. China is building something that sounds unreal at first, but it is very real and already happening. Beneath one of the busiest shipping lanes in the world, engineers are carving a massive rail tunnel under the sea. When it opens in 2028, trains will travel at 250 kilometers per hour, deep below the ocean, in conditions that would crush most structures on Earth. This project is called the Jingtan Undersea Tunnel, and it's quietly redefining what modern engineering can do. The tunnel connects Ningbo on mainland China to the island city of Zhoushan. On a map, the distance doesn't look dramatic. In real life, it has always been a challenge. Zhoushan is a major cluster of islands with ports, factories, and chemical plants, but it has never had a rail connection. People and goods relied on ferries, bridges, and long drives. Weather delays were common. Traffic bottlenecks were normal. For a country that moves millions of people every day, this was a weak link. China could have built another bridge, but bridges have limits. They interfere with shipping lanes. They take up surface space. They struggle in deep or rough water. A tunnel avoids all that. Waves do not matter underground. Storms do not matter. Ships pass above without even knowing what is happening below. A tunnel solves problems that bridges cannot. This tunnel is not small. The total length is over 16 kilometers, with more than 11 kilometers carved directly beneath the seabed. At its deepest point, it sits 78 meters below sea level. That's roughly the height of a 25-story building, turned upside down and buried under water and rock. The pressure at that depth is extreme. A mistake would not just slow the project, it would destroy it. To build something like this, China relied on two enormous tunnel boring machines. Their names are Dinghai and Yongzhei. Each one is about 150 meters long, which is longer than a football field. The cutting head at the front is nearly 15 meters wide. It spins with enough force to chew through solid rock day after day. Each machine weighs around 4,000 tons, about the same as several fully loaded airplanes. These machines do more than dig. As they move forward, they remove broken rock, install reinforced concrete rings to support the tunnel walls, and inject sealing material to keep water out. The tunnel is built at the same time it is excavated. Nothing is left unsupported. Nothing is left to chance. The ground they had to cut through was unpredictable. Some sections were solid granite, others were soft clay or loose sand. Over the length of the tunnel, engineers counted 28 different geological transitions. Each one required changes in pressure, speed, and cutting technique. If the machine moved too fast in soft soil, the ground could collapse. If it moved too slowly in hard rock, parts could wear out or fail. To handle this, engineers modified the machine specifically for this project. They added water injection systems to stop clay from sticking to the cutter head. They reinforced internal structures to handle the crushing pressure from the sea above. They upgraded the drive systems so the machines could run continuously for months without shutting down. One machine started from the mainland side, the other started from the island side. Both dug toward the center, deep under the ocean. This is where the real challenge appeared. These machines were not just digging holes, they had to meet each other. If the alignment was even slightly wrong at the start, the error would grow over kilometers. A mistake of 1 degree could mean missing the target by dozens of meters. There is no room to adjust at that depth. There is no easy way to stop and measure. Once you're underground, you commit. China solved this problem with its Beidou satellite navigation system. Beidou is similar to GPS, but for this project, it was pushed far beyond normal use. Engineers linked the satellites directly to the tunnel boring machines. The machines constantly sent their position, depth, and angle to the system. The satellites calculated tiny deviations and sent corrections back in real time. If a machine drifted even a centimeter off course, the system adjusted the cutting angle. Over thousands of meters, these tiny corrections added up to something incredible. When Dinghai and Yongzhei finally met under the seabed, the alignment error was less than 2 centimeters. On a tunnel more than 11 kilometers long, that kind of precision is almost unheard of. Once the machines met, the job was only half finished. There was a new problem. These machines were too large to remove. They could not drive forward and they could not reverse. Lifting them out was impossible. The solution was simple and clever. Engineers dismantled the machines from the inside. They removed motors, hydraulics, and control systems. Anything valuable or reusable was taken out through the tunnel. What remained was the outer steel shell. That shell was left in place permanently and became part of the tunnel's structure. The machines did not just build the tunnel, they became part of it. Construction is expected to finish boring work by the end of 2026. After that comes track installation, electrical systems, ventilation, lighting, and safety equipment. When everything is complete, trains will travel between Ningbo and Zhoushan in about 30 minutes. What once took over an hour by ferry or car will become a short, smooth ride beneath the sea. This tunnel's about more than convenience. It's about proof. China wanted to show that it can build long, deep, high-speed rail tunnels under the ocean with extreme accuracy. Many engineers believe this project is a testing ground for something even bigger. Across the Taiwan Strait lies a much wider stretch of water, about 130 kilometers at its narrowest point. The depth is greater, the currents are stronger, the geology is more complex. A tunnel there would be one of the most ambitious construction projects in human history. No one is saying it will happen tomorrow, but projects like the Jingtan Tunnel make it clear that the idea is no longer impossible. China has spent decades building infrastructure at a scale the world has never seen. It has built more than 45,000 kilometers of high-speed rail. It has crossed mountains, deserts, and cities with bridges and tunnels. Undersea construction was the final challenge. With this project, that challenge is being met. There are real concerns. Drilling under the seabed affects marine ecosystems. Large projects cost billions of dollars. Communities are sometimes displaced. These are serious issues, and they deserve real discussion. China is able to move fast because of centralized planning and massive investment. Not every country can or should copy that model. Still, the engineering achievement stands on its own. Underwater tunnels were once rare, risky, and slow to build. Now they are becoming repeatable. Techniques that once felt experimental are becoming standard. When one country proves something can be done, the rest of the world starts paying attention. The Jingtan Undersea Tunnel challenges expectations. It shows that high-speed rail does not have to stop at coastlines. It shows that oceans are no longer hard limits. It shows that precision measured in centimeters is possible, even under extreme pressure. When passengers finally ride through this tunnel, most of them will not think about the machines, the satellites, or the rock above their heads. They will scroll on their phones, sip coffee, and arrive on time. That quiet normality is the real achievement. This tunnel proves that the future of infrastructure is not about what sounds impossible, but about who is willing to build it anyway.